1.4 Transversals. A transversal is a line that intersects at least two lines in the same plane. There are several angle pairs formed by transversals. One such angle pair is corresponding angles. Corresponding angles lie on the same side of the transversal in the same position. To find the angle that corresponds with angle 7, I will slide along the transversal. In the same position is angle 3. Therefore, angle 3 and angle 7 are corresponding angles. Also, angle 4 and angle 8, angle 1 and angle 5, and angle 2 and angle 6. These are all the corresponding angles in this example. Another angle pair is vertical angles. One example in this diagram is angle 5 and angle 7. Another angle pair type is alternate interior angles. Alternate interior angles are found on opposite sides of a transversal between lines intersecting the transversal. Angle 3 is an angle inside the intersecting lines. Alternate interior to angle 3 is angle 5. These angles are both inside the lines intersected by the transversal and on opposite sides of the transversal. Another angle pair type is alternate exterior angles. Alternate exterior angles are on opposite sides of the transversal, outside, as in not between the lines intersecting the transversal. 6 is an outside angle, and alternate exterior to 6 would be opposite side of the transversal, outside the lines, angle 4. So angle 4 and angle 6 are alternate exterior. Another angle pair type is same side interior. Same side interior angles are inside the intersecting lines on the same side of the transversal. Angle 2 and angle 5 are same side interior. Also, angle 3 and angle 8. Next we have same side exterior angles. Same side exterior angles are on the same side of the transversal outside of the intersecting lines. So angle 6 is same side exterior with angle 1. Angle 1 and angle 6 are same side exterior. Also, angle 4 and angle 7. Transversals and parallel lines. These markings indicate these lines are parallel. Beginning with 1, we can see that angle 1 is congruent to angle 4 by vertical angles. Angle 1 also forms a linear pair with angle 3. Angle 3 is congruent to angle 2 by vertical angles. Angle 1 is congruent to angle 5 by corresponding angles. Angle 5 is congruent to angle 8 by vertical angles. And angle 5 and 7 form another linear pair. Angle 7 is congruent to angle 6 by vertical angles. And we can see here that angle 4 and angle 6 are supplementary because they have the same relationship as 1 and 3. Since line M is parallel to line N, there are only two angles. If M and N are parallel, then angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5 because they're alternate interior angles. Angle 2 is congruent to angle 7, and angle 1 is congruent to angle 8 because they are alternate exterior angles. Angle 1 is congruent to angle 5, and angle 2 is congruent to angle 6, and angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8 because they are corresponding angles. Angles 3 and 5 are supplementary, so are angles 4 and 6 because they are same side interior angles. Angles 1 and 7 are supplementary, so are angles 2 and 8 because they are same side exterior angles. Because of linear pairs and vertical angles, all acute angles in the diagram are congruent and all obtuse angles are congruent. Please take a moment to pause the video and attempt these questions. Angle 1 and angle 8 are alternate exterior angles. Angle 3 and angle 7 are corresponding angles. Angle 5 and angle 8 are vertical angles. With linear pair 180 minus 75, this angle is 105 degrees. Vertical angle, alternate interior, vertical angle, alternate interior, vertical angle. Here we have 36. So 180 minus 36 is 144. Vertical angle, alternate interior, vertical angle, alternate interior, vertical angle. 36, here we go. Vertical angle, alternate interior, vertical angle, alternate interior, and vertical angle. Theorems about angles along a transversal intersecting parallel lines. Corresponding angles postulate. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. The lines cut by a transversal are parallel if and only if the corresponding angles are congruent. And here's an example of corresponding angles. Alternate exterior angles. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. The lines cut by a transversal are parallel if and only if the alternate exterior angles are congruent. And here is an example of alternate exterior. Alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. The lines cut by a transversal are parallel if and only if the alternate interior angles are congruent. And here's an example of alternate interior angles. Same side interior angles. If two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. The lines cut by a transversal are parallel if and only if the same side interior angles are supplementary. And here's an example of same side interior angles. Same side exterior angle theorem. If two parallel lines are cut by a transversal, then the pairs of same side exterior angles are supplementary. The lines cut by a transversal are parallel if and only if the same side exterior angles are supplementary. And here's an example of same side exterior angles. This concludes the notes for 1.4 Transversals.